Our first resistor configuration that we are going to analyze is the series uh, configuration, resistors in series. So as we look at this picture, we see that with the resistors in series, there's only one path for this current to flow. So there's one path in series. And since there's one path, then all the resistors are connected in line, and the open ends from resistor 1 and resistor 3 are connected to our voltage source V sub T. Now each resistor is going to have a potential across the resistor. Notice my terminology. Across the resistor. We never say that that voltage flows through a resistor. Currents flow, voltages are across. So currents flow through I can't spell. Flow through devices, in this case resistors, and voltage or potential is across. Across devices. Okay. So the current flows through these three resistors, and we have a potential across each one of those that is related to our potential V sub T. And really, it would have to be that the sum of these would equal V sub T. And thinking about it, if there's only one path and the same amount of current flows through R1, that has to be the same amount of current that flows through R2 and the same amount of current that flows through R3. So let's set up our Ohm's law relationships. So we have V1 is equal to I times R1, and just for clarity we'll call it I1. And V2 is equal to I2 R2. V3 is equal to I3 R3, and V sub T is equal to IT times RT. And this is what we're interested in finding, is RT. Now, as we said, the voltage VT is going to equal V1 plus V2 plus V3, and we know that IT, I sub T, is equal to I1 is equal to I2, and that's equal to I3. So let's take our Ohm's law relationships and plug them into our voltage relationship. So I will have IT RT is equal to I1 R1 plus I2 R2 plus I3 R3. And now all the i's have the same magnitude, so I can cancel my i's out because they'll all come out, and I get my total resistance is equal to R1 plus R2 plus R3. And if I had more resistors in series, it would just be add the next resistor plus the next resistor, keep going on. So this is our total resistance. And basically that's what this is saying, is that this voltage source is really dumb. It doesn't know anything about individual components. All it knows is that it sees between its terminals a combined resistance of all these three together. It doesn't know about individual resistors.